What we're going to be going through in this video is how you can go ahead and create static methods in Java. So when you define a static method, the method is still a member of a class since you define it in a class, but the method can be invoked without using an object. So that's the one thing that you do not need to do is you do not have to create an instance of the class where that static method resides in. You normally invoke a static method by using the class name instead of the object name. So what we're going to be doing is we're going to create the following static methods. The methods are going to calculate the volume and surface area of a cube and the volume and surface area of a sphere. And what you're going to be passing in is in order to calculate the volume of a cube and surface area, you need the cube's side's height, and then for a sphere, you need the radius. So we're going to place these static methods into a class named geometry. Then we're going to write a test program called geometry tester that prompts the user for the values of radius and height, calls the four methods, and prints the results. And we're going to use Java's constant value for pi, and we're going to round the volume and surface area to the nearest whole number. So we'll go ahead and get started. So if I go out into JGrasp, what I've done is I've just copied my stub in here. So what I need to do is I need to go ahead and rename my class. It's going to call geometry. And then I do not need a public static main. We're going to be creating that in a separate class in our geometry tester class. So what we need to do is we need to go ahead and write create our four static methods. So we need to determine how you actually calculate the volume of a cube and the surface area of the cube. So what I've done is I've just gone into Google, typed in the search term volume of a cube, and voila, the information comes back. So the volume of a cube is just equal to the length of the edge cubed. So that is our formula. So let me go into, and then you could just do that for each of the other three formulas that you need for this assignment. So let's go ahead and type in our public, and then in order to make a method static, you use the static keyword, so it's public static. We're going to be returning a double, so what we're going to be returning is the cube's volume. And then the name of our method is just cube volume, and then what we're going to be passing in a double, which is the height of the edge. Okay, so we will go ahead and type in our formula. So what we're going to do is we're just going to go ahead and do a return right away. And then we're going to use one of the static methods found in our math class. So what that is the POW method. So what that does is you would go in and pass in our height as the first parameter. And then basically the second parameter is what power you want to take the height to. So if you wanted to square it, you would pass in 2. If you wanted to cube it, you would pass in 3. If you wanted to raise it to the 4th power, you would pass in 4, so on and so forth. So that should be all we need basically for our actual cube volume. So what we're going to do next is we're going to go ahead and write in our public static double, and what this is going to be is for our cube surface area. So again, we're going to pass in the double and the height, and what we're going to do here, the actual surface area is just 6 times the height squared. And instead of using the pol function, I'll just take 6 times height times height. So if we go out, change our search parameter to surface area of a cube, what it comes back is just 6a squared. So we will go back in and we will just return that value. So what we're going to do is we're going to type in our next method, public static. Again, we're going to return a double, and what this is going to be for is for our sphere volume, and what we're going to be passing in is a double for the radius. And we will go in and enter the information. So we'll go ahead and look up what it is. So volume for a sphere of a sphere. And what that is 4 divided by 3 times pi r cubed. Okay, so let's go back into our program here, and we will go ahead and return, and what it'll be is it'll be 4 divided by 3 times, and again what we're going to do is we're going to use the value that Java has stored for pi. So I'll just specify my constant math.pi, and what that'll return is the Java's value for pi, and then I'll just use my pol function again, and what we're going to do is we're going to go ahead and cube our radius. And then finally we'll do a public static double sphere surface, and again we'll pass in our radius, and we won't look up the actual formula. Basically what it is, it's 4 times pi r squared for the actual surface area. So it'll be 4 times our math.pi, and it'll be times radius times radius. Yeah, okay, and then let me add in my... Okay, so that should be our program. So what I'm going to do now is I'm just going to go ahead and pause the video, and I'm going to go in, let me go ahead and save this to give it a name of geometry. So what I'm going to do next is I'm just going to go ahead and pause the video and add my comments in. Okay, so what I've done is I've gone in and I've added comments describing each one of the static methods. So gone ahead, updated that with the comments, and now what we need to do is we need to go ahead and work on our tester class. So what I've already done in our tester class is that the user is going to be entering both a radius and a height. So I've already gone in, created my scanner objects, and prompted the user to enter both the radius and height. So what we need to do now is we need to go ahead and calculate call each one of the 4 methods to calculate the volumes and the surface area. So what we're going to do is we're just going to go ahead on all one statement, systemout.println. And what we're going to do is we're going to specify cube volume. and it'll be plus. And then what we want to do is we want to round the answers to the nearest whole number. So we're just going to go ahead and call the static round method that's in our math class. And then now the next thing I need to do is I need to call the method. So in order to call a static method, you just specify the class name of where the static method resides in. So it's geometry, and then it would be dot, and then it would be our cube volume, and then what we're passing in, which is our height. So we have that. So what I'm going to do is I'm just going to go ahead and copy this and update it. So cube volume. So what we want to calculate next is the cube surface area. So what we're going to call is the cube surface method instead of the cube volume method. And then we need to do the same thing for our spheres. So sphere volume. And then I will go ahead and make sure I call the right method. It'll be our sphere volume method, and then we have our sphere surface area. And then what we're going to do here is we're going to go ahead and make sure we call the sphere surface method. Okay, so that should be really all we need for our tester class. So what we're doing on lines 14, 15, 17, and 18 is we're calling each one of our static methods. To call it, you just specify the name of the class that the static method is in, dot, and then the name of the method, and then you need to pass in the appropriate parameter. And it looks like I've messed up here. I need to update my parameter that I'm passing in for my sphere is actually the radius that the user is going to enter. So, okay, so we will go ahead, compile our programs. They seem to compile correctly. We'll go ahead and run. What I'm going to enter is a radius of 10 and a height of 5, and what it returns is a cube volume of 125, the surface area of 150, the sphere volume of 4189, and the sphere surface area of 1257. So those are the correct numbers. I checked them before we ran our test case. So what we've gone through in this video is just how you could go ahead and implement static methods within a class, and then test those static methods with a tester program. So we will talk to you later.